Okay, so we are on the backside of day 6 notes. And in number 2, it says, when drawn in standard position, an angle X has a terminal ray that lies in the third quadrant and whose cosine is equal to negative square root of 5 over 3. Find the exact values of sine and tangent of X. Okay. So again, they said that we are happening in the third quadrant. So we will go ahead and draw our triangle. So we'll start at the origin. To get into the third quadrant, we go to the left and then we go down, and then we're going to connect that back to the origin. Okay, we'll put our right angle in there where we turned from going left and down. And remember, theta is always the angle inside the right triangle closest to the origin. Okay. Because they gave us the cosine trig function is equal to negative square root of 5 over 3. Some old horse caught another horse, taking oats away. We know that with cosine, this is our adjacent on top and our hypotenuse on the bottom. Okay, so in our right triangle, this is our adjacent side, this is our opposite side, and this is our hypotenuse side. And since they gave us square root of 5 is our adjacent side, we can put that up here. And 3 is our hypotenuse side, so we can put that here. Remember, we're ignoring all negatives, okay, for right now. All right, so since we're missing our third side, we'll go ahead and use a squared plus b squared equals c squared. And we'll go ahead and make sure that 3 goes in for our hypotenuse, so c. And square root of 5 can go in for a or b, doesn't matter. And we'll solve for our third side. So square root of 5 squared is 5. 3 squared is 9. We'll take 5 away to get 4. And we'll square root to get 2. All right, and now we can label our third side as 2. All right, we are now ready to go ahead and give them the trig functions they asked for. They want to know what sine is, so we'll say sine theta equals our opposite side over our hypotenuse side. So opposite side is 2, and our hypotenuse side is 3. Okay, we can't box that up until we know the sign on it. All right, so we'll do all students take calculus and realize tangent theta is the only one that's positive, which means we're going to have to add in our negative here for sine. And now that is correct, and we can box it up. Okay. They also want to know what tangent is, so we'll say tangent. And they used x, we used theta, it doesn't really matter. Okay. So tangent theta equals opposite over adjacent. Our opposite side is 2. Our adjacent side is the square root of 5. And we don't like the square root on the bottom, so we're going to go ahead and rationalize by multiplying by the square root of 5. And so tangent theta is going to be equal to 2 square root of 5 over 5. Okay? And remember, before you box it up, make sure that you have the positive or negative on it, and tangent theta in the third quadrant is positive, and so we're going to leave that fraction positive, and there are our 2 answers for the exact values. Okay? All right, coming down to number 3. In 3, it says if sine A equals 8 over 17 and angle A, okay, is between 90 degrees and 180 degrees. So on our graph, 90 degrees is up here and 180 is over here. So what they're telling us is that angle A is a quadrant 2 angle. So in order to get into quadrant 2, we're going to go and start at the origin. We're going to go to the left and up in order to get into quadrant 2. And then we'll come back to make our right triangle. Remember, theta is always the angle closest to the origin. And because they gave us sine, remember sine is opposite over hypotenuse. So in our triangle, this would be our opposite side. This would be our hypotenuse side. And this is our adjacent side. And they gave us opposite is 8. And hypotenuse is 17. And we're going to go ahead and use a squared plus b squared equals c squared to solve for our adjacent side. All right, so make sure that 17 is the hypotenuse. It goes in for c. And that 8 goes in for a or b, doesn't matter. All right, 8 squared is 64. 17 squared is 289. And when I take 64 away, I'm left with 225, and square root and b comes out to equal 15. So we'll have to put 15 down here. Okay, and they want us to find the exact value of cosine theta. So we're going to go ahead and say that cosine theta is equal to my adjacent side, which is 15, over my hypotenuse side, which is 17. And now before I box that up, I got to check my signs. So we got all students take calculus. And so we realize that sine theta is the only positive one. And so we're going to need to add a negative in to make our fraction negative. And there's part A. Okay. Tangent theta. So we'll say tangent theta equals our opposite side, which is 8, over our adjacent side, which is 15. And again, in quadrant 2, sine theta is the only positive, so we're going to have to add a negative in order to have the correct value here for tangent theta. Part C says find the measure of angle A to the nearest tenth of a degree. And so we actually have 3 ways of solving for our angle. We could say that A is equal to sine inverse of 8 over 17. We could say that A is equal to cosine inverse of 15 over 17. Remember, no negatives when you're finding the angle. Or we could say A is equal to tangent inverse of 8 over 15. Again, no negative, okay? So that you end up with a reference angle. All 3 of these should come out to be the same. And it's about 28.07 ... Okay. Now we have to remember that we need to get into quadrant 2. And so that's less than 180 degrees. Remember, reference angles come from the x-axis. So we're coming from 180. So we'll do 180 minus 28.07-ish. And that should give us our answer. And that's 151.927, ... They want it to the nearest tenth of a degree. And so we'll say 151.9 degrees is our value of our angle A. Okay, good. All right, let's take another look at another one, number 4. It says that the point 3, -5 lies on the circle whose equation is x squared plus y squared equals 34. And so in this one, what's a little bit different is that this is not the unit circle. If this was the unit circle, then it wouldn't be equal to 34, it'd be equal to 1. The radius is 1, okay? So it just changes it a little bit. It says, what is the exact value of the cosine of an angle drawn in standard position where a terminal ray passes through this point? So we'll go ahead and draw our graph. We're going to go ahead and plot our point 3, -5. So in order to plot 3, we'd go to the right. In -5, we would go down. Okay, we'll connect it. We'll make our right triangle. And so this is just a little bit different in that 3, since we went over 3, this distance here is 3. And then we went down 5, and so this distance here is 5. Okay, we're ignoring all negatives. Okay, we'll take care of that with all students take calculus. Okay. Now, I already know what the hypotenuse is, but if you don't, we could go ahead and throw our 2 sides of our right triangle into the Pythagorean theorem, making sure we're solving for the hypotenuse. This ends up being 9 plus 25 equals c squared. And 9 plus 25 is 34 equal to c squared. And I already knew that because that is our radius squared right there. All right. And so your hypotenuse comes out to be the square root of 34, which is what your radius would be. All right. So if you want a little tip or a little hint in order to skip all that Pythagorean theorem work, you could do that. All right. Remember, theta is right here, closest to the origin, that this is the adjacent side, that this is the opposite side, and this is the hypotenuse side. And they want to know the exact value of cosine. So we'll go ahead and set up cosine theta equals. Remember, it's your adjacent, which is 3, over your hypotenuse, which is the square root of 34. This is going to need some rationalizing because we don't like to leave the irrational number in the denominator. And so we'll go ahead and say that cosine theta equals 3 square root of 34 over 34. The last thing we have to do is check our sign. So all students take calculus, and cosine theta is positive, and this fraction is positive, so we can leave it. And there's our answer. Okay. All right, guys, let's take a look at number 5. In number 5, it says that point T, which is square root of 2 over 3, comma G, is located in the 4th quadrant of the unit circle. Determine the exact value of G. So this question is just a little bit different too. All right, but no big deal. We're going to use the information to get our answer. Okay. All right, so they said it's a fourth quadrant, so we'll go ahead and go over and down and back. We'll put our theta, we'll put our right angle, okay? All right, so the information that they gave us is the x-coordinate, and we have to realize that that's cosine theta. So cosine theta equals the square root of 2 over 3. And since that's cosine, we know that this is the adjacent and this is the hypotenuse. And in our right triangle, this would be our opposite. This is our adjacent, and this is our hypotenuse. And so now we can go ahead and put the square root of 2 on our adjacent side. We can put the 3 on our hypotenuse side, and we're missing our opposite. So we'll go ahead and do Pythagorean theorem. So that's a squared plus b squared equals c squared. We have the hypotenuse, which is 3, so make sure it goes in for c. And square root of 2 can either go in for a or b, does not matter. Square root of 2 squared is 2. 3 squared is 9. We'll take 2 away, we get 7. And we'll square root, and we get the square root of 7. Okay, and that can go on our opposite side now. All right, remember they want the exact value of g. And so what you have to realize is g is representing the y-coordinate, and that our y-coordinate is sine theta. So we'll set up sine theta equals our opposite side over our hypotenuse side. So opposite is the square root of 7, hypotenuse is 3, and then we just have to check our signs. So all students take calculus, and cosine theta is the only trig function that's positive, so we need to add a negative to our answer so that sine theta represents a negative ratio. Okay, guys. And so this is what g equals. All right, last question, number 6. It says an angle theta is in standard position and its terminal side passes through the point -2, -1. Find the exact value of sine theta. So we'll set up our quadrants. Okay. They said that we have the point -2, -1. So when we start at the origin, we're going to go over -2 and then down to do -1. We'll go back. There's our theta. There's our right angle. Okay. And remember that you went over 2 and down 1. Okay. And we're going to go ahead and label this as our opposite side, adjacent side, and hypotenuse. And you guys can see that the hypotenuse is missing, so we'll set up a squared plus b squared equals c squared. The 1 and the 2 are our a and b, so it doesn't matter which one's which. Just know that we're solving for the hypotenuse. Okay. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. And c is going to come out to equal the square root of 5. We can add that to our triangle. And now we are looking for the exact value of sine theta. So we'll say sine theta equals our opposite, which is 1, over our hypotenuse, which is the square root of 5. Again, we need to rationalize our denominator. And sine theta comes out to equal square root of 5 over 5. Okay. Last thing we need to do is check our signs. So we'll do all students take calculus and realize that tangent theta is the only one that's positive down in quadrant 3. And so we'll go ahead and add in our negatives so that sine theta represents a negative value. Okay. And that one's finished. So hopefully that helps on finding exact values. Okay. With our triangles drawn in the correct quadrants. Okay. All right, guys, I'll see you on day 7.